Hello, fellow chemists, and in this video we're going to take a look at the basic concepts of density and then solve several density problems. This is listed as a basic video because there's really no background information that you need to understand to be able to solve any of the problems that we do in today's lesson. So let's get started. So, what is density? Density is the ratio of the mass of an object to the volume occupied by that object. And if you're solving for density, the formula for density is equal to the mass divided by the volume of an object. And then if we take a look at density, we can see that there's three terms in density. This is just the symbol for density. There's the density itself, there's the mass, and there's the volume. So the three terms are the density, the mass, and the volume. As long as you are given two of those three terms, you can solve for the third term, and that's what we're going to practice doing today. So if you're solving for the density, you will take the mass divided by the volume. If you're asked to solve for the volume, you'll take the mass divided by the density. And if you're asked to solve for the mass, you'll take the density and multiply it by the volume. Now, of these three formulas here, the only one that you really need to know or memorize is the top one. Because if you have an understanding of the factor label method, you can actually use the density itself as a conversion factor to convert back and forth between the mass and the volume of an object. So you really don't need to memorize these other two versions of the density formula. So what we'll do today is we'll take a look at three problems and we'll see how we can solve them using the density formula. Density equals mass divided by volume. So let's get started here. The first problem that we have says if the density of a glass of wine is 32 milligrams per milliliter, how much would a 6 milliliter glass of the wine weigh in milligrams? So let's write down what we have and what we're asked to find. So we have the density itself, that's given to us as 32 milligrams per milliliter. And then we also have the 6 milliliters of wine. And then what we're being asked to find is the mass in milligrams. So if we write those out, we have 32 milligrams per, you can think of the per as just meaning divided by, milliliter. And then if there's no number there, you just put a 1 in. So that's the density that we're given. Now we're also given 6 milliliters. That's the volume that we're given. And then we're asked to find the mass, and it wants us to find the mass in specifically milligrams. So it wants us to find the mass in milligrams. That's what we need to look for. All right, so the first thing that you want to do is check and see, are all the units that you're working with the same? And what I mean by that is if we take a look at the volume, we're given that in milliliters, and the volume in the density is also in milliliters. So that's good. We don't need to change anything. If these volumes were different from each other, we would have to do an initial conversion before we could actually use this density here as a conversion factor. So let's see how that we would set this up. Now, the formula over here says that if we're solving for mass, we would take the density and multiply it by the volume. Well, let's see if that's what we end up doing when we solve this problem. Anytime you have a problem that has two terms, like 6 milliliters and then our 32 milligrams per milliliter, and one of the terms only has one unit associated with it, 6 milliliters has one unit, and the other term has two units associated with it, density has milligrams and milliliters associated with it, write the term down that only has one unit on it first, to the most left. So we'll write the 6 milliliters down first. And the reason you do that is it will force you to work from left to right, which is the way that we normally write and read. So we're going to use the density as a conversion factor. So we'll set up our conversion factor here. We have milliliters for our volume. We want the milliliters to cancel out, so we'll put that on the bottom. And we want to end up with milligrams, so we'll put that on the top. And if we take a look at our density for the volume, it's 1 milliliter. And for the mass, it's 32 milligrams. So we've set our problem up so that volume and volume cancels out. We'll then just multiply across and divide up. And when we do that, if we take 6 milliliters times 32 milligrams and divide it by 1 milliliter, 6 times 32 is 192, divided by 1 is still 192. And the unit is milligrams, because that's the unit that did not cancel out. And it wants us to find our answer in milligrams, so we did. And what did we actually do when we solved for our problem? We took the volume and we multiplied it by the density. And that is exactly what this says we would do. We would take the density and volume and multiply them together. So that's the first problem where we used density to solve for the mass. Now, in the next problem, we'll take a look at solving for one of the terms other than mass. So in the second problem, it says the mass of 75 milliliters of gasoline is 54 grams. What is the density of the gasoline? So again, we want to make sure that we know our formula. The density is equal to the mass divided by the volume. Well, what terms are we being given? Well, we're given 75 milliliters. That's a volume. So we're given the volume. And we were given 54 grams. That's a mass, so we're given the mass. And hopefully it's asking for the density. And right here it says, what is the density? So we are being asked for the density, so that's what we need to solve for. Now it says if you're solving for density, it's the mass divided by the volume. And so all we need to do for this one is we have our mass, it's 54 grams. And we have our volume, which is 75 milliliters. If we take our 54 grams and divide it by 75 milliliters, we end up with 0.72. Now, what units are on that? Well, the grams didn't cancel out, and the milliliters didn't cancel out. So neither one of those units canceled out, so the 0.72 has both of those units on it. It's 0.72 grams per milliliter, and that's our density. So we've solved for a density, and then we've also solved for a mass. In the last problem, we're now going to solve for a volume. So we'll see how we can solve for all three of the terms in a density problem. So if we take a look at the last problem, it says, what is the volume? What is the volume of an object in milliliters if it has a density of 42 grams per milliliter and a mass of 0.756 kilograms? Okay, so let's erase the board here. All right, so let's see what information we're being given. We're being given a density of 42 grams per milliliter, and we're being given a mass of 0.756 kilograms. So we'll again write out the density is equal to the mass over the volume. What are we being given? We're being given 42 grams per milliliter, and that is our density. And we're being given 0.756 kilograms, and that is a mass. Now, hopefully the problem is asking us to solve for volume. We can see right here, what is the volume? So yes, it is. So the volume is what we're being asked to solve for. And it doesn't say what unit it wants the volume in, so I guess we can put it in any unit that we want. So the first thing that we have to check is to make sure that all of the units on what we're given, and again, we're given the density and the mass, they're all in the same form. So we have our mass is in kilograms, but we can see our density is in grams. Before we can go any further and use the density to solve for volume, we have to get both of our mass terms either in grams or in kilograms. I'm going to pick to choose the kilograms and convert it into grams, but you could do it the other way if you wanted to and you'd get the same answer. So let's take our kilograms, our 0.756 kilograms, and convert them into grams. Again, this is a metric conversion, and hopefully you remember those from the previous lessons. There's 1 kilogram for every 1,000 grams. So we have it set up so that kilogram and kilogram cancels out. We then multiply across and divide up. And if we do that, we see that 0.756 kilograms is equal to 756 grams. All right, so now our mass terms are in the same unit. They're both in grams, grams for our density, and grams for the mass of our object. So now we can use the density to solve for volume. We have 756 grams. We'll use density as a conversion factor to convert back and forth between mass and volume. We want grams to cancel out, so we put it on the bottom. We want to end up with milliliters, so we'll put that on the top. And it's 1 milliliter for every 42 grams. So we have it set up so that grams and grams cancel out. We'll then multiply across and divide up. And when we do that, 756 times 1 and then divided by 42 will give us 18 milliliters. And that is the volume of a 0.756 kilogram object if it has a density of 42 grams per milliliter. All right, that's it for this video. In the next video, we'll take a look at some more advanced density problems, and we'll take a look at how you can use water displacement to determine the volume of a solid object if you're trying to use that to solve for density. I hope you learned something today, and I'll see you in the next video.